Hey guys, welcome back. So today I brought home this 3200 watt ETQ generator. This one was a Craigslist find. It was listed at $75, and according to the listing, it doesn't make power, but the engine runs well. So worst case, this is a parts machine. There are lots of good parts, but of course before tearing it apart, I want to understand what went wrong and see if it can be fixed. Now, the really interesting thing is that a couple days after I brought this home, a local subscriber reached out to me and said he had a generator that stopped making power and wanted to know if I could take a look. So let me show you what he brought me. He brought me a 3200 watt ETQ generator. It is the exact model as the other and is having the same problem. The engine runs, but there is no power output. So let's get both of these started. I want to test them and just validate that they both, in fact, do not make power and go from there. Find out what's wrong and potentially fix it. All right, let's give this a try. I checked the oil on both of them. They are both filled. They do need oil changes, but it's fine to test with. And I checked the throttle plates. They are not stuck. So let's give it a go. All right, this one definitely not making power. The only voltage I saw was 2.4 volts, and that is residual magnetism. So that tells me the rotor on this generator is not powering up. So either the rotor is bad or one of the components that supplies the power to the rotor is bad, like the brushes, the AVR, or potentially the DPE winding. So let's get the other one started and see if that one does the same. This one also only has residual magnetism. That rotor is not trying to power up. So whether it's the same cause or not, I guess that's what we'll find out. So let's get these inside. I'm going to start with this one, run some tests, see if I can't figure out why it won't power up. Let's cut to the chase. We'll get the end cover off the generator. See if there's anything obvious. I know it's hard for you to see, but there is nothing obvious. The copper color looks excellent. I don't see any signs of overheating. The wires look to be in good shape. So let's break out the multimeter and see what that has to say. To start with, I'm just going to check the main winding and also the connection to the brushes. I don't know what the value should be on a generator of this size, of this type. Usually it's between 0.4 and 0.5 ohms. On smaller generators like this, it could be all the way up to 1 ohm, which would still be considered good. Now, the best way to do this is to isolate everything and run your tests. In this case, I'm just going to do some quick tests with everything in circuit to see if there's any obvious red flags. .4 ohms, 0.5. That seems good. Let's check it to ground. And there is a connection to ground, which might be okay because everything is connected. And yeah, I see a jumper from ground that goes over to here. So this is actually a bonded neutral setup. So yeah, that connection's fine. Again, if you want to do a proper test, which we might have to do, you would remove that jumper and actually just disconnect all the wires from this wire block and test the coil directly. Anyway, let's get the wires off the brushes. We'll test through the brushes to the slip rings and see what the resistance is on that rotor. Well, that's interesting. The terminal, it just bent, or didn't bend, it moved. Huh. I don't think that's normal, but yeah, it's not. I can actually see there's a little piece of plastic right here that's broken off. So I don't know if that melted or if just the vibration caused it to move. It doesn't look melted though. Huh. Let's get that one off and we'll test it. And I get nothing through the brushes, but based on what I'm seeing, I'm hoping it's the brushes that are bad, because the other possibility is a bad rotor, and that I can't fix. So let's get the brushes out, test on the slip rings directly, and hopefully we get a reading somewhere between 40 and 70 ohms. Oh, wow. Looks like the brush heated up and it melted the plastic holder, allowing it to move out of place. So that's actually a good thing. You know, this does happen sometimes when the brushes arc. They generate heat and it melts the plastic. So I'm guessing we are going to get a reading on the slip rings, and most likely the slip rings have to be cleaned. Because if it was arcing, I mean, it could have been a defect in the brushes or maybe a little bit of junk on the slip ring. So let's just check the ohms, make sure we have a good reading. And we do. It's 49 ohms. So that's good news. The rotor is good. The stator seems to be good. It's just a bad set of brushes. So I'm going to pull the spark plug out. I'll get a wrench so I can rotate the engine while just holding some Scotch Brite on the slip rings to clean them up. It's a torch. It's difficult to show you the slip rings, but if you look at the slip ring on your right, that one is dirty, but it also feels quite rough, and I'm sure that was causing the arcing. So cleaning it, hopefully, will get rid of some of that roughness. Otherwise, it could be a chronic problem. You know, if that's rough and is causing arcing, then the brushes are going to heat up and the holder is going to melt. So With the spark plug out, it should be easy to turn the engine over just with a socket and hold a piece of Scotch Brite on there. Just be sure not to knock into the wires that connect to that slip ring. They break pretty easily, and once broken, it is very difficult to repair. Unfortunately, I'm out of the green Scotch Brite. That's what I usually use. I've heard pencil erasers also work. In this case, I'm going to try blue. Hopefully that's good enough. Been working at these slip rings for quite a while, and they're about as clean as I can get them. They're not perfect, especially the slip ring on the top. There is some pitting and imperfections, and it was quite rough. You know, now it is fairly smooth, but I'm not sure if it's smooth enough, especially right there. The damage is pretty bad. You know, I don't know if that was caused when the brush overheated, or if that was pre-existing, and that's what caused the brush to fail in the first place. Anyway, let's get a new set of brushes on there and try this thing out. Spark plug is reinstalled. Let's see what we get. I think we might be good. I did not see any arcing. The slip ring, it is warm, but it's not burning hot, and it's not any hotter than this bolt is right here, or kind of the rest of the housing. So I think we might be okay on this one. So let's pull the end cover off the other and see what's going on with that one. So what do you think? Same problem with this one? Nothing obviously wrong with the brush holder, and the stator wires look pretty good. I don't see any broken lacing. Color looks decent. Although down there it does look a little suspicious. So let's get out the multimeter and see if we can't find out what's wrong with this one. On the last generator we had 0.5, 0.4 ohms. We're at 0.5, 0.4. So that seems good. Let's check through the brushes. Interesting. That terminal, it is wiggly. Kind of like the other one. And I think I almost see the copper coming through the side. So maybe this one did overheat. Those brushes are stuck pretty good. So that's a good sign. Tells me the brushes most likely are the issue. So let's get the AVR out of the way and see if we can't get those brushes out. Look at that. Exactly the same issue. The brush, it must have been arcing, caused the housing to melt and the brush moved out of place. All right, should be an easy fix. Let's take a look at the slip rings, see what kind of shape they're in. Got the spark plug removed, like last time. And you can see the slip ring on the right. That's the one that had the broken brush. And there was a lot of carbon buildup. And it doesn't feel too rough. Maybe a little bit right there. Yeah, this one doesn't feel too bad. Should clean up pretty well, I think. They're cleaning up, but it is slow. The blue Scotch Brite definitely not as effective as the green. I think that's about as good as they're going to get. There's a lot of low spots, which you can still see the carbon where those spots are. These slip rings, though, they are pretty smooth compared to the ones that were on the other generator. You know, if anything, I'd say the slip ring on the left is a bit more rough, and that one had the good brush. So Let's get some new brushes on. I think we're good to go. Make sure you put the positive on the left brush terminal. I'm pretty sure this is going to work, just like the other generator. It's a little late outside now, so I can't really run this outside, but I'm going to start it real quick and just make sure that light comes on. This one scared me for a second. I was expecting that light to turn on right away, and it didn't. But as it turns out, the light switch was off, so once I turned it on, we could see it was making power. We were at 119 volts, 62.5 hertz. So this generator lives again like the other. So the question in my mind is, why did these both fail? Were the brushes poor quality, or the slip rings? And my money would be on the slip rings, at least on the first one we fixed. Even after cleaning the slip rings, you could see they were damaged. And I'd say that one, more likely than not, will cause another brush failure at some point in the future. This one, the slip rings looked a lot better, so I think this one is fixed. Anyway, I wasn't sure where this video was going to go. I really expected this to be a teardown video. Usually when these stop making power, it's because of a bad power head. But in this case, a bad set of brushes is an easy fix. And if you have a generator that's not making power, check the brushes. It could be that simple. So, I hope this video helps someone. Thanks for watching.